Hello, and welcome to BIM Design Studio, where we build smarter and design better. In today's video, we're diving deep into one of the most essential topics in the building information modeling, the BIM dimensions. What do we mean by 3D, 4D, 5D, or even 10D in BIM? Let's break it down from 1D to 10D and understand how each dimension adds a new intelligence layer to your model. First, before talking about the BIM dimensions, we must have full knowledge of building information modeling itself. So if you haven't watched our video on the introduction to building information modeling, make sure that you have watched that video first and then get back to this video. We rarely hear about 1D in BIM, but it exists in the background. It is where it all begins, defining the project's purpose, scope, and feasibility. It's about asking, is this project viable? Here, stakeholders outline goals, budgets, and risks. Example, a city planner evaluating infrastructure needs. 2D represents the world of plans, sections, and elevations. Think CAD drawings or blueprint sets. This is where most projects used to start, flat drawings on paper or screen. While 2D is still vital in documentation, it's not considered BIM until it's connected to a 3D model. Fun fact is that over 60% of firms still use 2D for initial client approvals. Now this is where BIM officially begins. 3D is the digital geometric representation of a building, the virtual model. It includes elements like walls, windows, doors, and all spatial relationships. With 3D BIM, coordination and visualization take a leap forward, helping us identify classes, improve design intent, and communicate more effectively. Tools like Revit and ArchiCAD let teams visualize and resolve issues early. Example, detecting a pipe column class before breaking ground. For the BIM integrates time into the model. It links construction activities to the 3D components, enabling construction simulation, phasing, and project scheduling. This helps stakeholders visualize the project timeline, detect delays, and improve coordination on site, all before construction even begins. Imagine linking your model to a Gantt chart in Navisworks to simulate construction phases. Delays spotted instantly. 5D adds a financial layer, linking cost data to model elements. This allows us to automate quantity takeoffs, monitor budget impacts in real time, and support cost planning decisions. No more manual calculations. The model does the math for you. Ever heard of a $10 million project avoiding overruns? Thanks, 5D. Sixty focuses on sustainability and energy performance. By integrating environmental data, designers and consultants can analyze the building's carbon footprint, simulate energy usage, and make decisions that align with green building goals. This dimension is crucial for achieving certifications like LEED or BREEAM. Example, a net zero design optimizing solar gain. '70 turns the model into a long-term asset management tool. It contains detailed information on equipment, warranties, manuals, and maintenance schedules. For building owners and facility managers, this means streamlined operations and lifecycle planning long after construction is complete. 8D introduces health and safety measures into the model. It can help in identifying hazardous zones, planning for safety protocols, and ensuring regulatory compliance during construction. This proactive dimension supports a safer work environment. Use Synchro or Fuser to simulate hazards and plan mitigations because no project is worth a life. 9D focuses on efficiency, process improvement, and waste reduction. It supports the principle of lean construction, optimizing workflows, eliminating non-value-added activities, and enhancing collaboration across the supply chain. Think modular hospitals in weeks, not years. Finally, 10D explores the future. Smart building technology. It integrates IoT devices, automation systems, real-time sensors, and advanced analytics to create intelligent, adaptive buildings. This dimension connects the physical with the digital, enabling predictive maintenance, user-driven environments, and smarter cities. From 1D big data to 10D city-wide vision, each dimension solves real problems. Adopting higher BIM levels means fewer errors, faster delivery, and sustainable outcomes. So, to recap, 1D research and planning, 2D drawing, 3D modeling, 4D time, 5D cost, 6D sustainability, 7D facility management, 8D safety, 9D lean construction, and 10D industrialized construction. The journey from 2D drafting to 10D intelligence shows how BIM has evolved into a holistic approach to building design, construction, and management. If you found this video helpful, make sure to like, subscribe, and hit the bell icon to stay updated with more in-depth BIM knowledge right here on BIM Design Studio. And let us know in the comments which BIM dimension are you currently implementing in your projects. Thanks for watching, and as always, build smarter, design better.